Okay, so hello everyone. Today we will see how we can perform post-order traversal, that too in non-recursive form. Before this, we have seen non-recursive pre-order traversal and non-recursive in-order traversal. So if you could not watch that video, please go and watch that first so that you will understand this one. So for performing this non-recursive post-order traversal, we will require two stacks, or we can say we will require two instances of stack so that we can perform here a post order traversal. So how we can perform, we will see. So the steps are very simple here. So what we will do is, I will just tell you the steps first. Like whatever the node you are visiting here, it all this time starts from the root. So we know that what is our root. So root is here 7, so we will start with the 7 only. Okay, so if you are visiting 7, so we will just push that 7 into your stack. So into your first stack you will push 7. So let's say I have here 7, I will push that 7 into stack 1. So into my stack 1 I will have here 7. That's it. After that, what we will do, we will just keep checking until stack 1 is not empty. I will keep popping the element from stack 1 and I will keep pushing it into stack 2. So until S1 is not empty, I will keep popping the element from stack 1 and I will keep pushing that into stack 2. So if I will push that 7 into stack 2, so I will get 7 here into stack 2. Okay, so 7 is now deleted from first stack. Okay, so in my first stack I don't have now 7, so 7 is present into stack 2. So this is the thing that I got. Apart from this, what you can do, after deleting any element from stack 1, you should just keep checking, do I have any left child for that deleted element and do I have any right child for that deleted element. So if you have any left child and right child, so successively just add those elements into stack 1. So first what you can do, you can add a left node into stack 1. So left node of 7 is 3, so I will add here 3. Okay, next to 3 I have again a right element is what, 5. Again I will add 5 into my stack 1. So into stack 1 you can see now at top I have 5. So again I will go with my previous condition. Previous condition is until stack 1 is not empty, keep popping the element from stack 1 and push it into stack 2. So if I will pop the 5 from stack 1 and if I will push it into stack 2, so I will get again 5 here. Okay, so 5 I can add here into stack 2. Okay, it's been deleted from stack, we can say 1. Now as you are deleting again 5 from stack 1, again do check for that deleted element, can I have a left child and can I have a right child. So for 5 I have a left child, so I will insert 6 here. So I will add 6 into stack 1 again. So as 6 is added, what you will do, you will again keep checking, can I delete that 6 from stack 1 so that it will be empty. So yes, I can pop that 6 from my first stack. So I will delete 6 from first stack and I will push it into stack 2 again. So 6 will be added here. Okay, after this what we can do, again I will again check for that 6, can I have a left and right child. So for 6 doesn't have any left and right child, so don't think about it too much. Then do check what element is present into stack 1. So into stack 1 I just have 3 now. So again I will delete 3 from stack 1, I will pop 3 from stack 1 and I will push it into stack 2. So 3, if I will push it into stack 2, so I will get 3 here, it will be deleted from stack 2. And as I will delete 3 from stack 1, I will again check for that 3, can I have a left child, can I have a right child. So yes, 3 has a left child, 3 also has a right child. So just add those left and right child into stack 1. So left child I will add first, it's a 2, and after that I have a right child also, that's a 1. Okay, so both the nodes are being added. After that again do check, is your stack 1 empty? No, it's not empty. So for that again do check until stack 1 is not empty, keep popping the element and do check, does it has again any left and right child. So if I will pop the node from stack 1, so I will get first node is here 1. Okay, so 1 I will remove from stack 1 and I will push it into stack 2. Next element, again for that popped element, do check what is the left of that popped element and what is the right. So one node has no left and right, so don't worry about it. Now think for a next node. So next node is here only 2. So again remove 2 from stack 1 and push it into stack 2. So I will remove stack last element, that is 2, and I will push it into stack 2. So you can see now the stack 1 is completely empty, though you will check for 2 do we have left and right child, so we don't have. So in this case stack 1 is completely empty. Okay, so here the stack 1's role is finished. So what we can do, we can now perform operations for stack 2. So here how we can perform, or how we can get a traversal, that to a post order. So for post order, what we require just a post order traversal. Okay, post order traversal. So just give me a minute. So for this post order, how we can get here the sequence that we will see. So for this post order traversal, you can just do see what steps I will perform. I will just do the simple step. I will remove every node from stack 2 and I will print it. So if I will do the pop operation for stack 2, so the first element that will be popped is 2. So I will get first the pop node is 2. So 2 will be my first outcome. Next, if I will do pop operation, so I will get 1. So I will get here 1 as the output. Then again, if I will pop the next node, so it's a 3. So I will delete 3 and I will print it. Again, if I will perform pop operation, so I will get 6. So I will print it again. Then if I will again do the pop operation, so I will get 5. So I will write here 5. Okay. So all the popped node from stack 2 I am printing. Then at the last I will again pop 7 and I will print it. So this is the last element. If it's not looking properly, I will again draw. So this is 7 actually. So this sequence, that is 2, 1, 3, 6, 5 and 7, this is what, this is your post order traversal. So you can see like at last we are getting here a root of your tree, that's a 2 1 3 left, right and root. Then we are getting 6 5 and 7. So this is actually the correct post order sequence which we are getting by this process. So now we will go with a C++ code for this post order traversal. So for this, what things we require? We require here some basic things. First thing that I need to create is a tree. So for this, you will require a node class. I will just increase the size. Okay. So for doing this, you require to first create a node class because you want to create a binary tree. Then you need to ask user to create a tree, so you will require some create function. Okay. Then the third thing that you require here is a stack to perform some insertion and deletion operation, that is push and pop operation. And at last you require some post order function to perform post order traversal. So here you can see, if you are regularly watching this videos, so you can see like the first three things we have already discussed into previous videos. So if you still have not watched those videos, so please go and watch those so that you will understand how now we will implement post order traversal. So here in this code, we will just go and we will see what things we have. So this is what, this is the first thing that we require is node class. So node class is readily available with us. Okay. Node class is available to us. This is available. Okay. The next thing what we require a create function to ask data from the user. So create function is also available to us. We have seen how to create this create function, or how we can ask the user to provide some of the nodes as a left child, right child, and what will be the root. So all the explanations we have seen. Then the third thing that we require here is a stack. So create function and stack, here you can see it's already mentioned. How the stack performs push and pop, that also I have explained into previous video. So now what we can do, we can simply go for a post order function. So I will just write the name, it's void post order. You can pass any temporary node. So I will just write, it's, let's say, some class type pointer. So this is your post order function. So into this function, I require two stacks. So I will write their instances. So stack S1 and S2. These are two instances that we have created. So what is was the first step? So first step was we are keep pushing the nodes into stack 1. So what I will do, I will say the current node is, let's say, temp. So I will just keep pushing that temp into stack 1. So this is my first step. I will write here s1 dot push, and what I will push temp there. So this is my first step that I will do after just the initialization of stack. After pushing the node into stack 1, what we will do, we will keep checking until the stack 1 is not getting empty here. You will keep popping the node from the stack 1 and you are pushing that into stack 2. That was our steps. So what I will do, I will just provide the condition until stack 1 is not getting what, -1, not equal to -1. So what is -1? It indicates actually whether your stack is empty or not. If your stack is empty, it will be -1. The top will be -1. Again, I am telling you all the waivers, like we have explained this into previous videos. So please go and watch that. So you will understand how we are doing this. Okay. So here again, what we do, until the stack 1 is not empty, we are just popping the element from the stack 1. So I will write here s1 dot pop. Okay, those pop nodes will be stored again into some variable. I will say again it's a temp. You can write any name, it's not mandatory you should write temp. Okay, and where you should store that pop node, you should store into stack 2. So I will write here s2 dot push. So this popped node which is stored into temp will be stored into now stack 2. So I will write here this one. Okay, so s2 dot push means whatever the nodes I am popping from stack 1 is getting stored into stack 2. That is the meaning of this one. Okay, after this, what do we perform? We check if for any pop node, if the 7 was the first pop node. So for first pop node, what we were checking, can that 7 has any left child or does it has any right child? So if you have left child and right child, so we are first pushing left child here, that is 3, and then we were pushing 5. So here into stack also you can see, first we have pushed 3, then we have pushed 5. So I will check for first if that temps left is, let's say, any valid node, means it's not equal to what, null. It's not equal to null. Then what you can do, you can simply push that temps left into stack 1. So I will write temps left is now getting pushed into stack 1. Okay, so this thing we are doing. After that, I will also check, can I have a right child also available? So I will just write here for the temps right. If it's not, let's say, null, then again push that temps right into same stack 1. This thing we will do. We are keep going to do that thing until your stack 1 is not getting -1. Okay, so these things will be keep repeating. After that, if these things are now finished, so you know that this instance will come when we can say stack 1 is completely empty. So if this thing is now becoming false, so all the nodes are now getting stored into stack 2. So how we are providing or how we are getting our result for the post order? So what we have done here, we have just done a pop operation. We are popping the node and we are printing it. So same operation we will do until stack 2 is not now -1, it's not empty. So I will just write here the condition, like let's say while we can say s2 dot top node becomes what, -1. Till that time I will just keep popping the node s2 dot pop, Okay, from stack 2 I am popping and I am just printing it. So what thing you will print? You will print its data. So I will just print here its data. So you can write here temps data. So whatever the node you are popping, you are just printing its data. So that's it. It's the only requirement of your post order. So again, I am explaining what we have done. We have first instantiated two instances of your stack class. After that, we have pushed the node into first stack. Then we are just checking until the stack 1 is not getting empty. We are popping the element from stack 1. We are storing into one variable, and that node we are pushing into stack 2. After that, we are also checking, can I have any left child? Yes, if it's exist, so I will push that left child into stack 1. If you have a right child also, again push that into stack 1. If this doesn't exist, so this block will not execute. Okay, after that we are just checking if I have, let's say, some of the elements which are popped from stack 1 and that are pushed into stack 2. So I will just check until that stack 2 is not now becoming empty. I will keep popping the element from stack 2 and I will keep printing their data. So that's it. It's the only requirement we have. So now what I will do, I will just create a tree with only 3 nodes. So what I will do is I will say the root is, let's say, here 5. For 5 the left child is what? Here we can say 4. 4 has the left child, let's say nothing, it's -1, and right child is also -1. So what is -1 here? Into previous video I have explained what is the -1. So -1 we have written here. If x is here -1, so you are not printing or you are not declaring any node, you are returning null. So here I am telling force left and right child is -1 means you are not creating any new left and right child for 4. Now the control is moving for root, that is 5. So 5's right child is what? 5's right child is, let's say, 3. So for 3 again, left child is -1, right child is -1. So here you can see we got 4, 3 and 5. So what is this 4, 3, 5? So you can see how the tree was created. So tree was created like this with just a 3 nodes. These 3 nodes were created. So I think this was 5. The root was 5 here. The left child was, I think, 3. Or just let me check, it was 4. Right child was here, I think, 3. So you can see if you will perform now here post order traversal, so we should get first the left child, that is 4, then you should get right child, that is 3, and at last you should get root, so that is 5. Hence we are getting the output here 4, then 3, and then 5, like this. So same output we are getting into post order. So you can check here also 435. So this is your post order reversal by using C++ code. So I hope you understood this. So if you still have any queries into your mind, so please post your queries into chat box, or you can just ping me on any social network. Okay, so thank you for watching.